Anyway, it's a super exciting day. Zach and I are teaming up for our first episode of Beyond the Blackboard, our new math education podcast. Yeah, I'm super jazzed. I think the timing is great. I'm excited to be here, excited to talk about math and education. That's was my background when I was in Winnipeg. So I was helping out both the mathematics faculty as well as the education faculty with teacher training. So I think it's very near and dear to my heart, and I know it's pretty near and dear to yours as well.
It is. It is. And I'm super excited. So, um, here's the impetus for what we hope to accomplish here, I
Periodic
think,
noise,
is to talk
grade
about
9,
math education issues that come up. And today we're going to talk about a book that we both,
Bring me
I think, really like.
math,
I
vector,
suggest this
integral,
book.
or group math
It's one of my
factor.
favorites called
Det,
Building Thinking
grad,
Classrooms by
D-
Peter Liljedahl. I'll show it on screen. You can see it in pretty clipped. It's fairly clipped. there you go. There's Penn's version of it. You probably get a better view of it that way. But this book is about thinking classrooms, and you might be thinking, well, aren't all classrooms thinking classrooms? And we're going to dive into that today and talk a little bit about what makes a thinking classroom and whether or not the classrooms you experienced maybe have been thinking classrooms, and maybe talk about some of the classrooms we've experienced as well.
Yeah, and we definitely want this to be interactive. So if you have questions, if you have comments, throw them into the chat for us. I'll be kind of scanning through and picking out some things that I think are potentially interesting for us to talk about and to disseminate. I know Rex was saying that Obi was studying the book too, so I think it's a pretty well known text. Would you say, Zach?
I would say so. Among K-12 teachers, you notice this thing says K-12. This is a book that I wish I had been able to read. This came out. Copyright date here is on 2021. This came out after I got out of the classroom. And I left the classroom about 2020, but I also knew of Liljedahl from a previous seminar I had gone to. So I knew of him, and actually he was pretty instrumental. His philosophy is pretty instrumental in how I did things in the classroom. And I'm glad to now actually have a tangible something to read that reminds me of all the stuff I knew.
Yeah, so I think is he Canadian? Is he from British Columbia?
He is. That's what I understand. Yes, he graduated. If I remember, it says here in the intro. He's from Canada. I know that. But he's from Simon Fraser.
Oh, SFU. Okay, I thought he was was from one of our big 6 institutions here. I just couldn't remember which one. Hi, Martin. Welcome in.
Yeah. Well, so that's that. We're going to talk about classrooms today, and I guess let's kick this off by talking about classroom experiences and maybe what you have experienced in the classroom. Like, what's normal, right? What do you experience when you walk into a math classroom?
And I would say, for those of you that are in chat right now, please feel free to drop your experiences. What does your typical classroom look like? Like, what do you do as the student? What does the teacher do as the instructor? How do those pieces interact with each other? I'm always curious to know how things look at different institutions. For me, I went to Brock University. That was my undergrad in Canada, and it was a very, very traditional style of teaching. So it was you'd sit in your lecture hall with 150, 200 other students, and you'd take down your lecture notes. You'd get some assignments along the way, and there'd be some tests and a final exam, and you kind of dust your shoulders off from the carnage moving into the next classroom, basically.
Yeah, basically. Mine was very similar. I went to classes. Granted, so I went to Brigham Young University here in Utah, and I had a very similar experience where you go to a big lecture hall for many classes. For math, they were much smaller classes, I found, usually capped around 40 or 50, which was nice. But even so, I felt like, again, it was a lecture-based classroom. Did a lot of here's a lot of note-taking. They gave you lots of material to learn, and you had to learn it, and you had your finals, and you had your tests, and you had the long hours of homework. I remember one calculus assignment taking over 5 hours, just for one homework. It was hard.
Yeah, I can definitely attest to that. I feel like one thing that actually I feel has changed a lot. Sorry, I'm a little distracted because I'm just trying to adjust to get you a little bit more centered here.
That's fine.
One thing that I think has changed significantly, and we should talk about this at some point, is felt in my undergrad there was a lot more emphasis on getting together collaboratively with other people to solve stuff. And I think we've started to move away from that getting together and doing mathematics collaboratively, to a more of like an AI focused solution. So that's been really interesting to see over the last like 10 years or so.
Yeah, the collaborative based things are really cool. I have so what I was I found that so I should say that the very beginning of my undergrad experience was very much lecture based. When I started going to teacher college, I started experiencing a lot more of what you were experiencing. Right, we had a math education department where you were talking about having people in groups and solving things in groups. A lot of the tasks, we're going to use the word tasks here. We're going to define that in a little bit. But in the introductory courses for the math education degree, we spent a lot of time doing tasks, these problems, together as a group, discussing things and talking about things. And not, I didn't have a word of lecture in some of these classes. It was very rare that lecturing happened. And there's been this shift towards it, and there you might rightly be wondering why. Like, why would I want to change something that seemingly works for people, right? Like, I mean, it's
Right.
what we've always done, and like, so why would we need to change it all? Why is this even a thing? And we're gonna get to all that today. That's hopefully that's one of our big ideas we want to talk about. Is like, why would a shift be necessary at all?
And I think Floofy says, you get the info from the book, you come to the lecture to hear the prof talk through the info and ask questions, maybe, right? And we can talk about that a little bit. I never felt comfortable asking questions because I thought I would look like an idiot, right? So I very rarely ask questions in a traditional lecture setting. And then he says, he or she says, maybe they tackle the problem set, maybe you go to office hours to ask about the problems or to get some help, and then you try to finish the problem set. So that's pretty much what I would say was my undergrad experience as well. The reading courses were better, and I agree that it was a bit more of an opportunity. Like, I started doing reading courses when I got to like my master's here. I was in central Canada in Winnipeg, and those were a lot more fun because it was like me. I had a mentor. There was a lot of trust put on me to do some of that reading, to figure out where I wasn't understanding the material, and to take that back to my supervisor and say, hey, like, please explain how I do this particular operation on a manifold. Oh my gosh, right? Like, so I liked that aspect of reading courses for sure.
Well, I was even like I got to the point where I was scared to ask questions, like to the point of like I was almost reprimanded for asking questions. It felt like I was getting like socially outcast, if you will, by some professors. And this happened in both undergrad and grad programs. Like, I felt like I wasn't given the space to do that, and that can be really hard.
I've heard that from a lot of students where they try to ask questions to better understand the material that's being talked about. And what they get from the professor is that feeling of like, yo, you're an idiot if you're asking me this question because you clearly don't know what's going on. And I'm like, well, that's such a bad way to be teaching mathematics.
Like, I told a story of this once to a grad professor in my grad program. That it happened to me once where I had asked a question, and the professor that told me, well, you just got professionally slapped in the face when you're told not to ask that question. Basically, like there's this sense in which it's almost not worth it's not worth the. Sometimes when you ask a question, you have to you want to save face, right? You want to save like social face in front of your peers, and that's a very real concern. Like, you want to make sure that you can learn, and get your questions addressed, but you don't want to look like the person who's not smart. There's this social, like, I want to keep my appearances as positive as possible.
Yeah, yeah. Well, no one ever wants to look dumb in front of their peer group, right? Like
And
I don't want to.
if you've ever seen my streams, you see me look dumb at least 50% of the time. So I've gotten over that to some degree, but I still feel it in some professional contexts where I'm going into a classroom and I'm taking a class. This happened a lot in grad school. It happened a lot in undergrad. It just happens, right? We have this I don't know how to say it, but this fear of looking stupid, and
Yeah.
that affects our ability to get help.
Yeah, yeah, exactly. I think that's one thing I like about streaming mathematics on Twitch is it has made me very humble because there's lots of stuff I don't know how to do, and you just have to ask questions. You have to ask for that assistance. So yeah, I've appreciated being able to do that.
Yeah. I was just checking the chat here, and uh, yeah, Flofi is talking a little bit about this. Some professors have a very flawed idea of the average level of their students, right? So I've seen that. I know that. In my mind, it's better to make fewer assumptions than not. We're gonna get into all that and what Liljedahl has researched and discovered, as the case may be. But
Floofy also apologizes for the text to speech. That's totally
it's fine. No, I'm reading between the lines. I'm trying to. Chat is difficult to communicate with. I mean, think about any text message you've ever sent, right? Like you've ever sent a text message. You know how hard it can be to communicate via text.
Yeah, all I know is I haven't had breakfast and I got really hungry when I read that sentence. So,
awesome.
we've talked a little bit about the importance of being able to ask questions and get answers to questions. So I guess, like, how do we build that capacity, right? So is there a way for us as educators to build the capacity to ask those questions? And how do we, I guess, motivate students to feel comfortable asking those kinds of questions too?
So this is excellent, and I'm going to use a phrase that sometimes is used politically. It has political charged connotations, and I don't mean it that way. I'm going to use it in a very different way. I'm going to say that we need to build a safe space. And when I say safe space, what I mean is we need to be able to feel like we can ask a question, right? That there's this leveling of a classroom, that it's not the teacher against me and my fellow peers against me, if in some sense, but that we're all working together to understand things. There's a sense of camaraderie, right? And this is very difficult to build. There's actually an interesting book called Motivated that talks about this. And some teachers, when they try to implement a task, for instance, again, we haven't defined that word, and we're going to define that word, but when they try and do some kind of problem-solving something or other, if people aren't able to ask questions and there's not a leveling of the playing field, then those tasks typically fail. Problem-solving doesn't happen, and so on.
Sorry, I'm just writing something down because I thought it was interesting. So leveling of...
Please do, yeah. I think leveling is a huge... Like, we need to level the playing field so that everyone has an opportunity to attempt what we're trying to teach. That we have a... Sometimes in the literature I hear the phrase low effective filter, which is a way of saying I have an accessibility point for as many students as possible. I have the least amount of requirements in place so that I can approach this new content in a comprehensible way.
There's a phrase that I hear a lot in education. I know that Liljedahl defines it somewhere. It's something about like low ceiling or like low barrier.
Yeah, right, a low ceiling. I think that's another way of saying. I'm using the technical term here, low effective filter, but the same concept of low ceiling.
Yeah, I got you. Okay, so he defines it on page 23. Low floor.
Low floor, high ceiling. That's what I was trying to get. That's what you're going for. But the low floor in the sense that I have a low barrier to entry, but I have a high ceiling in the sense that I have the opportunity to extend the task to something more general, as mathematicians are wont to do. Say I'm doing something with factorials, and I'm Pascal's triangle, and I find a pattern that works for row 5. The high ceiling might be, well, does it work for all rows in the table or in the triangle, right? Like, am I able to prove this statement? I may notice a pattern about row 5 or row 10, or even all the odd numbered rows, but is it true for all of them? And as mathematicians want to do, they want to generalize. That's where the high ceiling can come in, right? Maybe that's not the point, is to generalize to all rows, but it's to see it in a certain subset of them. So,
yeah, but I like what you're saying here, because I think that, like, fundamentally we are kind of programmed to see we're programmed to see pattern recognition. So I think, like, right, even just something as simple as pattern recognition gives a diving board into a lot of these tasks that I'm sure we're going to talk about throughout the series.
oh yeah, yeah, we're going to talk a lot about tasks, and we're even going to talk about a few today. I'm excited because I told Penn that I'm going to give you something today that you have not seen before. I promise it's not crazy, but it's going to be fun.
I wish I could recall very quickly the names of the cities from when we were teaching linear algebra. Was it Flippy Flop Town or something?
Flip Flop Town. Yeah, it was something like that. I could probably find it somewhere.
I was like, oh no, it's going to be a task from Flippy Flop Town.
No. That's the one you gave me. I'm only giving you back.
I mean, you owe me. You owe me.
I owe you. Yeah. I owe you a little bit. I won't be that mean, but.
I like Floofy's comment here. If anything, a question usually signals an attempt to engage with material. I like that statement a lot.
Yeah, and berating that question doesn't help. But we'll talk about. We got some. This is good. I like this. I like what we're talking
about. All right. So, do you want to? You've talked about this thing called a task, and I'm wondering if it's helpful for us to kind of put some parameters and try to define what we mean by task, and that might help kind of move the conversation towards kind of chapter 1 here.
We've alluded to it, and I think we need to. I'm going to quote here from Liljedahl, because I think the way he talks about it is useful, or paraphrase. And if you happen to have a copy of the book, it's page 19. But
I do happen to have a copy of the book, Zach.
Wow,
what are the odds
for
of
our
that?
viewing audience, if you're happy to watching this and you're like, I don't know what the heck you're talking about, page 19 says, so when you talk about a task, he uses the phrase, or he uses the sentence, he talks about this thing. I don't talk about what a task is, but rather what a task does. Right? So trying to define a task should be in terms of what a task does. And the example given here is, which is greater, 8 or 9? And I think many viewing members of our audience would say, oh, well, that's a silly question. Why would you ask that question? Now, first of all, think about what we just said, right? Don't. Somebody asked the question, you shouldn't belittle it. But at the same time, for many of our viewers, I think that question is not so helpful to learn anything, right? This is a question that would not be an interesting task for us to talk about, because I think most of us would know the answer if I were to venture, right? But a task is meant to for someone who maybe was a kindergartner. I'm thinking of some of my or even my some of my kids who are below kindergarten age. This would be an interesting thing to talk to them about. Say, which is bigger, 8 or 9? They know one of my girls happens to know her counting numbers, can say the numbers from 1 to 10 in order, but hasn't connected cardinality yet. This could be an interesting task for her. And why is it interesting? Because it causes her to think and reflect, which is, I think, was what the big idea of a task is it causes someone to think and reflect about about a new mathematical idea, or about a previously visited mathematical idea.
Yeah, I'm just going to go ahead and share my screen just for a minute, because I think this is an interesting piece of conversation.
And Dr. Gold, I don't start the 6-7 memes. We're not doing that today. Just saying.
So I don't know if you've had a chance to read The Number Sense by Dehaene. But
I'm not familiar with that one, no.
So Dehaene goes through kind of like the biological way that people might think about developing this idea of number sense. And one of the more interesting things that came out of me reading that was this understanding that as we're developing numbers, we tend to be very good at seeing one. The difference between 1 and 2, we can see very quickly as we're evolving through this. But as soon as we get to like more than 3, things get very tricky. So if I were to like put a bunch of stuff here and say, okay, well, how many dots do I have over on the right-hand side? You're going to have to process that a little bit, because we were kind of just biologically evolved to see 1, 2, and a lot. So I want to connect this back to the question that Liljedahl asks, which is greater, 8 or 9? This is a great question as we're starting to learn about number sense, because I actually have to put effort into thinking about what is bigger, right? And it helps develop that number sense for people that don't have it yet. And I completely agree with Zach when he says, yeah, if I take this into my first year calculus class, they're just going to be like, why are you asking me this question? It's already been routinized for them. They already know how to work with, probably work with dealing with relationships between integer numbers.
And so in defining a task, we have to think about the audience we're giving it to. That's, I think, a key defining feature is if we're going to give a task, why are we giving it and who are we giving it to? What mathematical idea? And one of the things I was drilled into me, I don't know if I told you this story, Penn, but I should tell you. When I was in teacher college, so my undergrad teaching college, I actually failed my methods course. Did I tell you that?
No way. What?
No, I failed it. I got it. Well, I failed it in the sense that I got a D. And so I had to retake it, I guess is what I'm trying to say. And the reason I had to retake it was because I thought that when you taught mathematics, the way that my teacher college was set up was very much problem-based. And I thought you could just give an activity without thinking about the purpose, and you'd succeed at teaching. And my professor was like, no, you can't do that. My lesson plans came back with low marks just because I didn't think about the mathematical purpose. And I've since learned that you got to have a purpose. And I took it the second semester and knocked it out of the park, because I finally learned the lesson of, if you have a purpose to your lessons, then your tasks will make sense. And like, there should always be a task and purpose connection, right? Why you're giving something. So if you're going to give this 8 or 9 task, cardinality task, you should think about why you're giving it and who you're giving it to.
Right. Gold, what? You failed quantum in grad school? What?
Bruh.
I didn't know that.
A B minus counts as failing. I mean, like in grad school, that's just the way of things. I don't know how to... Just the way it works here in the States, at least.
Yeah, so you were saying that the methods class, I guess, kind of nudged you in the direction of being able to think about not just creating a task, but thinking about the intended audience and the intended learning outcomes from that task. Am I capturing what you tried to say there?
100%. And that's why I bring it up, just to illustrate that when you give a task, think about why. Like, why would you give this to somebody? And to ground this experience, we have to now contrast. A task is meant to help us learn something new about mathematics, but you could argue that a lecture could do that. So what differentiates a task from just a lecture? Or what differentiates a task from a problem set? A task, we have to then think about what it encourages us to do. And what a task encourages us to do, generally speaking, and there are different levels to which you can do this, and there's various feelings. There's lots of researchers who have talked about this subject, but generally speaking, a task asks you to problem solve. And right. The best tasks are ones that ask you to problem solve in a way that doesn't have an algorithm at first, or that you don't know the algorithm. Ideally, this will help you develop an algorithm or develop an algorithm efficiently. Maybe you do have an algorithm, but it's sort of nebulous. But you're always engaging with content in a way that asks you to not just be algorithmic about it. Or if you're algorithmic, you're pattern noticing. You're not focused on on doing some traditional exercise, right?
Yeah, I'm sorry. I realized I got called out in chat. Math
You
pedagogy
got called out.
specialists in Canada usually refer to learning outcomes. That literally popped into chat as soon as I said the words learning outcomes. So I'm like, I feel a little triggered right now. I felt like I had to get that off my chest before we move
That's
forward.
fair. No, you're fine. You're fine.
Yeah, I think you bring up a really interesting point. This point that if we're doing practice just for the sake of going through the motions of that practice, are we really thinking? I think that's the question that you're asking.
Mm-hmm. Yeah.
And I feel kind of I feel like it's going to be good cop bad cop in this in this podcast, Zach. You're going to be good cop and I'm going to be bad cop. But I always feel like a little balanced about this. I think that I'm always very partial to the idea of mixing up practice rather than blocking practice. So as soon as that practice starts to feel very routine and feel very algorithmic in nature, it's actually time for you to move away from that and do something else, because you're not really doing the level of thinking that you need in order to make things connect and make things make sense. I'm not sure if I'm explaining myself well, and feel free to bounce some ideas off of me.
Two thoughts here. Actually, as you're talking, because the brain, if it's all it's doing is thinking in the Liljedahl sense, I think that's actually a really bad thing, because it's almost too high level all the time. We don't operate well at high levels all the time. We need some things to, we end our workday after 8 hours, say, and then go home and maybe chill and watch Netflix. That's a completely acceptable thing to do. The brain needs rest. The brain needs sleep. The brain needs all these things. And so, like, when we need time to socialize. We need time to. So, as humans, it's not always possible to do deep thinking all the time. And several different paradigms and different, like, theoretical frameworks, as we say in the business, in the academic business, but they're just ways of thinking about how people think. They account for different depths of thinking, right? So, for example, Jim Cangelosi, who's actually on my committee, and he wrote a book that we used in our undergraduate preparation programs. Dr. James Cangelosi, he talks about learning levels and saying there's reason to discover a relationship. There's reasons to construct a concept, but there's also reasons to do algorithmic skill and have simple knowledge tasks. And there's reasons to do all these things that we just have to think about the different reasons why we're doing something. If I'm developing a new idea, I want to construct concepts and discover relationships. But I want to also give time to practice some algorithms, because that's not necessarily bad, and those are okay tasks. But when we're talking about tasks here in building a thinking classroom, the thinking that we're talking about is encouraging us to problem solve, and ideally problem solve in new ways. That's the part we don't see very often. We see the algorithmic skill, and we should actually go back. Now that we've sort of talked about what a task encourages problem solving at its very core. And the level to which we problem solve, I suppose, is different. But Liljedahl did some interesting research. This is where I want to pull the book in and talk about why do we need things that are non-algorithmic at all. And if you he went into classrooms, and he has this lady named Jane that is really interesting. This is an interesting case study. He was just finishing his PhD, and this teacher came up to him and said, "Hey, I want you to come and help me do problem solving with my students." And he went in and found there were some struggles, I guess, to put it mildly, of implementing problem solving for the first time. But he went in and noticed that students, when they would work on a problem solving task at first, they just didn't engage. Right? That there's this sense of I don't know what to do, that kind of thing. And as he continued to go to different people's classrooms, he worked with this lady Jane, but also worked with some other teachers around Canada, and started taking data, and found that when teachers just ran the traditional classroom, only about 20% were engaging with the the tasks, the questions given by teachers that were very algorithmic skill, I do, we do, you do. Only about 20% were engaging in an authentic way. Others were just like trying to copy what the teacher was trying to do, but you can't see that very well. There's Penn trying to.
It's too bright.
So it's pie chart.
I'm overexposed.
The lighting's a little weird today, but students would often shut down, and some wouldn't even try. Some wouldn't even like in a traditional classroom, mind you, and maybe you fit into one of these categories, but there were people were trying to mimic what the teacher was trying to do. People just gave up. People were acting like they were trying to do something, but really were just trying to wait for the teacher to give an answer, and all kinds of off-task behavior 80% of the time, with only 20% engaging the way the teacher wanted. Which says something, right? And if your goal is to think and not mimic, the task the teacher gave wasn't very effective for its purpose. So the task of just giving an algorithmic skill, like here's how you write an algorithm, and then I want you to sort of do a similar example. That didn't cause the thinking, and it didn't have the intended effect that the teacher designed. And it's not just this one teacher, Jane, but it was actually, he asked Jane where else he could go and view, to watch other teachers do the same things. And as he went to about 40 different teachers, this little pie chart Penn's showing is about the distribution of how students engage with the tasks teachers gave. Where mimicking took about mimicry, meaning like the students would try to copy what the teacher was doing on the board, and then some would fake it, which I thought was interesting. I'm not surprised at all, because that's sort of human nature, and I found myself doing the same thing, where I'll try to just fake my way through something, and I don't know how to proceed, right?
Or like, I think Fem brings in an interesting point here, right? When I put a practice problem on the board and walk around the classroom to check and see how students are doing, there's always some students who would tell me they're just going to wait, right? So that's the stalling, right? They're just stalling. They're just waiting for the teacher to go back, because they know the teacher's going to go back and solve that question for them. So this is kind of like a learned behavior inside the classroom.
Yeah. And so if we were to call this a task, which some would say, yes, these tasks that are algorithmic skills, asking, it's the teacher trying to get data, giving some example, and you can imagine anything. Say I'm doing some factoring problem, and I say factor x squared minus 9 into linear factors, then and then you're walking around monitoring whether people can factor difference of squares, that may... You'll see this distribution of kids in the room more often than not.
Yeah, I think Hitch also brings up an interesting point here. Like, I feel motivation when understanding where the thing I'm studying fits into kind of the overarching goal, right? Like, understanding what's the point, how does it connect to something that I already know, right? It gives us motivation to initiate things as an individual. Totally. I think that's a very interesting comment to read from chat.
Yep. Okay, so yeah. The tasks that Liljedahl advocates for, if we take tasks in its most broad sense of just encouraging us to think, well, you could argue that the difference of squares task I just gave you could cause you to think, and it might, depending on the context. But what Liljedahl's found is that not all tasks are created equal, and some will encourage, and even like the situations and contexts in which we give tasks, whether we have, for example, furniture in the room or not, whether we have the grading structures in place that teachers will use to evaluate student work, can affect how students work on a task. The way we ask the question, whether we ask it verbally, whether we ask it on paper, or in other things, can affect the engagement with the task. And we're going to talk about all these things throughout the next few weeks, because this is like, all of these deserve their own discussions.
Yeah, there's certainly there's some chapters in the book that I'm really excited to read. I mean, I've read the introduction, I've read chapter 1. I kind of have a general sense of what Liljedahl is thinking about with regard to tasks, but I'm also really curious about the implementation piece, right? So, so he brings in a lot of interesting thoughts, And now I'm curious about, okay, how do I, as a teacher, how do I actually take what Liljedahl is thinking about kind of theoretically and bring that into my classroom in an actual concrete way?
So if I may, I'd like to give it. I think this is a good time for me to bring in your not your torture, but your opportunity to learn.
Okay, okay.
So like I want to do a task today. This is a task I've done many times over with students, and I see the roll of the eyes, the subtle roll of the eyes as I'm watching the delayed video. I love it. Anyway, we're going to do a task here, and in chat you can do this as well. I invite you to think about it. And we're going to watch a video here.
Oh, okay. Are we going to watch it on your side, right?
We're going to watch it on my side.
Okay, let me get set up. So you should be set up now to show a video.
Okay, so I'm going to do that. This is from Dan Meyer, and I'll put the link in chat in a little bit, or in the show notes once we get this all out there and finalized, so you can see it. It's called Nana's Paint Mix-Up. And there's not much audio here, so I'm not going to feed the audio through, but I want you to just watch the video and think about the situation and think about what you notice and wonder. And I invite chat to do the same, okay? So here we go. This is the Nana's Paint Mix-Up. Let's go.
Lab time. Let's go. Let's do it, Rex. Okay, so I need you to mix a 1 to 5 ratio, I saw. Okay. That was very bad mixing.
That wasn't, yeah.
It could have been mixed better.
It could have been mixed better.
Oh, it was supposed to be. Oh no! 5 red to 1 white. Oh no!
So, what do you notice, Penn? Like, what's your first reaction to this whole thing?
My first reaction is that he's wasted all this paint. Paint's expensive in this economy.
It is. Well, and it's getting more. Yeah, I was gonna say in this economy, it's even worse, right? Like, we're. So, I'm curious. What do you think of that question at the very end?
I love a Clockwork's comment. Don't use a scoop. Don't use a scoop. So my initial question at the end is it possible to save the paint that we've already mixed?
Yeah. So let's go back, and I mean maybe we should go and look at what's here. This was the badly mixed paint, and I've had students say before, like, you shouldn't be mixing paint like this. You should be using different scoops, right? It annoys them sometimes when I show this, because you should.
Those are also probably the people that are like, don't let my vegetables touch my potatoes, kind of people.
Right. But like seriously, what could we do about this? How could we address the concern of, like this store owner, I can imagine, is sort of frustrated now. And who hasn't had a situation where you're like, oh shoot, I made the wrong order. Oh crap, can I undo that? Like, this is I feel like this is symbolic of a lot of different things you could do. But what's your thought? Can you fix this?
Yeah, there's a couple of comments coming in chat. So Joseph says add 24 red. Clockwork says add 24 red and 4 white. Cos Milano says plus 24 reds. So seems to be a consensus about 24 reds that might need to be added. I'd be curious to know why you're saying 24.
Yeah.
So where did 24 come from?
Yeah. Well, and Penn, what are your thoughts? Like, what's your reflection here? What do you think of that plus 24? Does it work? Does it?
Fem says 24. I mean, I'm just looking at chat, and I'm happy to go the direction of chat. What I do notice is that if we were to add 24 red to this mixture, that would get me up to 25 reds to 5 whites. So I do notice that.
Okay.
So is that the ratio that we need? I don't know. You might need a bigger mixing pan, maybe.
Right? Right?
So yeah, so I think there's some advantage to getting 24 more in because now we have multiples of 5 and we can think about groups of 5 rather than groups of 1 for the overall mixture, if that makes sense, Zach.
Yeah. So there'd be 25 red and 5 white. And how does that satisfy what's this final request is supposed to be? Because I don't see the numbers 25 and 5 there. I see the numbers 5 and 1. So how is that the same thing? Like, how can you claim that this problem's solved
Right. I
by
need
adding
to. Can I?
24?
I might need to draw something
Yeah.
to think about this. So give me just a moment to do that. One, two. I'm gonna count 3, 4, 5, 6, 7, 8,
And if you want me to, I can take this off and we can put
30, 40, 50.
yourself back on. Oh, there we go.
1, 2, 3, 4, 5. And you can let chat cook too. If there's anything in chat there that you want to think about. 1, 2, 3, 4, 5. While I'm drawing my beautiful rectangles.
JCYW, I love of that. Violate the second law of thermodynamics. That's there you go.
What does that mean? Just like unmix everything and then remix
That's
everything.
Right. Well, and Cosmolano has an interesting thought.
Oh, I like that.
Scoop out a fifth, then you effectively have one white and 1/5 of a red. So add 4 and 4/5 red if you want the same amount. Oh, interesting. We'll have to come back to that. I'm interested in that one.
Yeah, I'm curious about that one as well. So I think here's kind of what chat had originally thought about. So I have a couple of rectangles here. Each section, so the upper rectangle, let's call this red, because this is what we're going to have. Thank you for the work, Famished. Good luck with whatever you're up to. So what did we have initially? I guess we had white and red. So we had one red to 5 white initially. 1, 2,
That's
3,
right.
4, 5. Okay, so we really haven't added any more white. So this shaded red is what we had originally, comparatively to the bottom piece. And I think it's kind of interesting to note here that that we were kind of comparing these tiny slivers of the rectangle. I think that's interesting because when we go to add all of the rest of this red, so this is me representing adding the 24 extra scoops of red, for example. Now I'm thinking that rather than thinking about these little slivers, I'm now thinking about this block as a single piece of measurement. So maybe it's helpful for me to like remove this. So now I have one thing like this, and I can come through and I can start removing 1, 2, 3, 4, right? So there's one block of red now. 1, 2, 3, 4. There's my second block of red. 1, 2, 3. So I'm kind of like taking my pieces and I'm kind of increasing them to get a new kind of measurement out of it. So 1, 2, 3, 4. 1, 2, 3, 4. So now everything is in groups of 5.
I see.
And now I can see that I have 1, 2, 3, 4. Now I have 5 reds to 1 white.
And I like what you did right there. You took the 25 red scoops and made them blocks of 5. Right? I think that's the key thing that we need to realize is we can now say, and I this would be good to write down, I think, just to solidify.
Sure.
25 red to 5 white is the same thing as 5 red to 1 white. If I take those, by taking a group of 5 red scoops, I now have 5 red blocks to 1 white block.
Okay, I think I've captured what you wanted me to say there. So these two, I'm using the dots here to represent ratios. So these two ratios are equivalent in some sense then.
Yeah. I like it. Well, and that's isn't that interesting? Like now, what have we effectively done is made a proportion. So if this were an actual like lesson, I would say this is a proportion. This a proportion is where we have equal ratios, and the equal ratios are that each one of these one major blocks turns into five scoops. And we could talk about unit rates and so on, but the idea here is the task that I gave you led itself nicely to developing a ratio and developing a proportion.
Right. So in some sense, I'm just kind of marking down what you said here. So there's this idea of 25 to 5 being equivalent to 5 to 1, and the movement as we go from the left side of that equation to the right side of the equation was us understanding that we could rearrange our blocks, right? So instead of blocks of 5, we can rearrange stuff in blocks of 1. So the red arrows here are representing that we've kind of regrouped stuff in groups of 5 rather than groups of 1.
Yeah, no, I agree. So now let's be a little meta here. What was different about this than trying to have you go through and just like tell you what a proportion is and have you solve some proportion problems, right? What's different?
I think there's a couple things that I would like to highlight here. So the first is that you have a problem that, like, the fundamental question is fairly straightforward. Shoot, I made a mistake when I was mixing some stuff. Rather than dumping everything out, do I have an opportunity to save what I've pre-mixed, right? So it's a pretty, I think, easy question for students to access, right? Like, so it was very easy for me to be like, okay, I can kind of see the problem here, and how am I going to fix that? Well, I'm obviously going to fix that by trying to add some more red paint. How much do I have to add? I kind of popped over into chat and everyone seemed to have a consensus of 24. So I kind of rolled with it and I kind of drew what I thought was a visual representation. And I liked your follow-up question of, well, wait a second. Now you have 25 to 5, but your grandma wants 5 to 1, right? So kind of prodding us to make that connection, right? So I think your overall goal here is to get to this idea of equivalent proportions, or maybe even equivalent fractions, and you've prompted us to think about that with that follow-up question.
Which is designed to do that, right? Like giving a task without having a purpose in mind is rather silly. If my but when I have a goal in mind, my goal here is to help you think about what a ratio is, and that I can make equal ratios. Now, to contrast this, it's funny because last night, one of my kids is actually learning about this, and I gave this to one of my kids, and they came up with the same answer. It made me really happy. We were good there. But then I saw my kid doing homework, and I'm going to go over to the chalkboard real quick and write something down because I just want to show you. Here's the contrast of what you might see in a classroom that was a little bit irritating.
Sure.
So let me jump over to the chalkboard cam. Okay. So chalkboard cam, here's what it was. Fill in the ratio table. And it looks something like this.
I think your cover's on your camera, Zach. Oh, there you go. Beautiful.
And there are a certain number of rows, and maybe you see something like this. I'm making stuff up just because I need something to work with. And how about 98 just for measure? And we'll throw it down a 7 here just because. And I'm asked to fill in the missing blocks. Now, to me, you might be saying that's the same, I'm getting the same purpose. But I wonder what this is like. Let's compare and contrast the two prompts, right? If I give you this paint task, that's great. But then I give you homework that looks like this. I mean, you could argue that, yeah, maybe these are good tasks. But if I lead out with this task about filling in a ratio table, I don't know. It doesn't feel as effective. I'm not thinking about ratios. I might just be copying what the teacher was doing or something. I might be falling into the traps that Liljedahl was is warning against. I don't know. What are your thoughts?
Yeah, I would say that. I mean, if you're going directly from this more kind of structured thinking task into doing something like that, I feel like students might not see the connection. Right, there might be a disconnect there. That would be my biggest concern.
Right.
So
And I guess
I think there's room here to move from the video, which is a very kind of hands-on, like there are tangible items that Dan is working with as he's mixing, to what I provided, which is like a visualization, right? So it would be like one level of abstraction, a visualization representing the tangible objects. And I think there might need to be a little bit more time in that middle phase, right? Like I like the idea of using a video like that to get that initial engagement, that initial motivation, figuring out how you can take that tangible piece, deliver it in an abstract way by using a visualization, and then I think you have to live there a little bit, and then once students are comfortable there, then I think you can make that transition to completely abstract, which is just numbers, right?
yeah. No,
That
and I
would
think
be
that's
how I feel about the progression of something like this.
and it's interesting you were talking about the progression, but you there's that low ceiling. We don't or low floor. I mean, the low floor here is that we have a task that people can relate to. The mathematics is not crazy. I mean, it would be appropriate for maybe a grade six student. If I were I've given this task to sixth grade students. I've even given it to high school students, and I've given it to college students before to help them think about ratios. And it's interesting when I did this task with sixth graders, I had very different experiences than I did with those who are older than sixth grade. And it's because sixth graders haven't seen this content before, so they have to really think about it. And the thinking that goes in to doing something like this versus maybe a high school or college student thinking about this problem, or all of you in chat who had a solution very quickly. Um, you know, the thinking here it just requires different thinking depending on who you're talking to, which again speaks to the audience in which you're talking to in doing a task.
Yeah, definitely. There was that one answer that I thought was maybe interesting for us to review. So
Was it Cosmolanos?
yeah, scoop out 1/5 of the mixture, then you effectively have
Yeah.
one white and a 1/5 of a red. So add 4 and
Ah.
4/5 red if you want the same amount.
And that makes sense, I think. The tricky part there, effectively, that does the same thing, but what you'd have to be careful of is what does it mean to be 4/5 of a scoop? I then would be like, well, we have a measuring problem a little bit because if I just have these scoops that are discrete and there's no markings on them, that might prove difficult, especially fifth cup markings or fifth scoop markings. Those that's not a common dividend or divisor. I was correct. Common divisor of measuring tools.
Yeah, that's a very good comment. I can't remember the last time I've seen 1/5 of a cup of something when I've been
Not to
baking.
say you couldn't do it. You could. I just don't see it very often.
Yeah. We'd have to get a little clever, I think, with how we figure out how to find 1/5 of the thing.
Well, it's like those puzzles you've seen that say fill the water tank with 6 cups, and you only have a two and a or what is it? Some relatively prime numbers. You have like 5 and 7.
Buy this mana
You just somehow
graduated cylinder. Nice. Sure. I don't usually have chemistry supplies in my baking cupboard.
I mean, you never know.
I love that. Great comment.
Okay. Well, there's an example of a task. I think it's good to ground in examples, but I don't think that's the only task we could give.
And I think a lot of it too is, like those of us that are here in chat and that watch the video, we kind of already understand this process of ratios and how ratios are connected to fractions. But that's a really hard concept for people to understand. I mean, I think there are even people, at college and university levels that still struggle with working with fractions, right? So, I think you need to develop that a little bit slower, and I think having that kind of tangibility, being able to access a question like that, and then understanding how we can transition that into a visual kind of way, or maybe even using like linking cubes or something would be a good tangible way if I want to abstractly visualize something, but in a tangible way. So I think those are the transitions that I tend to advocate for when I was like prepping my future teachers.
Yeah. Yeah, this is as tangible as you can make it. It's good, I feel.
Get this man a more accurate grandma.
I love it. Well, okay, so this is good. I think, let's see here. What other things do we want to talk about here? I want to make sure we talked about this task. Now, just before you think that all tasks have to be these visual tasks that have meaning in the real world, they don't have to be. I want to show another example, if that's okay.
Yeah, totally.
So here's one that's a little bit more interesting. This is going to be a geometry task.
Oh, I do love me a good geometry task.
Okay, so here we go. Can you all see a blank white screen?
Yes.
Okay. So here we go. Ready, set, play.
I'm just going to say that I really love this animation, and I actually used this animation we had a bunch of high school students that came over to the college, and I showed them this animation, and it was based on a problem out of Stewart calculus, which is like you have a certain length of pipe or metal wire, and you have to take a certain amount of that metal wire, transform it into a square, and a certain amount of that metal wire, transform it into a circle. And the idea was to maximize, I think, the area.
Well, so maybe we can think about that, like the maximizing area here. That's one thing. Dr. Gold is saying, who will win, circle or square? That's an interesting question, right? Who will win? And in what way are we talking about winning, right, Dr. Gold? What does that mean to win this? If it means area, certainly that could be.
Signal, actual 242 gold hands, exit.
Triangle wins extreme diff.
Triangle wins. Stop.
But in all seriousness, like, let's think about some questions we could answer about this picture. You were talking about area here. Like, is there a place where these two areas would be the same? Maybe.
Yeah, that's an interesting question for sure.
Because, like, where would you stop the video, would you say? I know there's delay here, so where do I stop?
Well,
trying to go slowly.
But this is cool too, because like now you have a way to bring in this idea of estimation, which we don't often do a lot. At least I find at the level like where I teach. Mm-hmm. So I mean, right here, somewhere. I mean, I feel like maybe somewhere in there. But even then, I feel like the circle is slightly bigger than the square. But I mean, I feel like I'm roughly in the neighborhood of where I want to be. Plus or minus an h.
Yeah. But it's interesting here, right? Like, where is it that, like, this invites us to be more rigorous, right? And to say, okay, I find it interesting, if it's me, that there's no labels on this line segment. The line segment has nothing on here.
Right.
Which makes me think, okay, the question doesn't really ask me what to calculate anything per se. It asks me to prove something. So if I'm going to talk about area,
like
well, if you're going to talk about area, I have to. I mean, I might need to calculate some stuff, but my calculations are going to be in terms of variables, and I'm more likely to write proof here, like in a more general sense, than trying to do like you're going to be doing calculations. Don't get me wrong, but it's about the relationships between the blue and the red, right? This red seems to make a circle, this red segment, and this blue segment seems to make a square in some way. Which, I mean, how are those related? We haven't even talked about that. But the concept here is I have to think more abstractly. Even though this is grounded in a visual, I still have a level of abstraction I have to engage with.
Right, and I think like Cosmolano is correct, right? Like, what's the question, right? And
what's the question? We didn't ask a question. We're trying to define our question. This is a part we don't talk about in math education at all. What's the question? We need to like define it. Penn suggested, what if we try and find where areas are the same? Right? That was one suggestion.
But I think Fem said that as well.
Fem said that as well. Yeah.
Gold says, who will win, circle or square? Does that just mean like, is the square bigger when we find the area on the far left? Is the circle bigger when we find the area on the far right? I don't know.
And that's part of what a task can do. And this is what's beautiful about this question, or about this video, not even a question, but like this video, is you get to, as a teacher, define the question. Now, if I, as a teacher, want you to investigate area, I can certainly direct students towards calculating areas, and we could have a conversation about that. But other students may be more interested in perimeters, right? Or circumferences, or maybe like the ratio of the lengths of sides, or whatever. There's lots of questions we could ask about this, all of which may be relevant. Maybe it's not about who's going to win. Maybe it's something about like at the very end over here. Like maybe I could ask a question about this part of the video. Fast forward a bit and say, well, how does this area of the circle relate to the area of the square?
And even Joseph has a really interesting question here. When are the perimeters the same? And I think Joseph is suggesting that we might not even need variables to answer that question.
Right. And these are all questions that are approachable with this 45-second video. I have opportunities to engage with math in an authentic way and involve students in the process of creating the question, which we do so little of.
And this is interesting because I always hear a lot about, people talk about differentiation a lot, Zach, and I think this is an exceptional task for that. You arrange students into groups, they kind of collaboratively decide together in their groups what's the question that they want to answer, and then you kind of just let them go, right? And now you have a bunch of different groups potentially thinking about different questions. And to me, that feels like the differentiation piece, right? So we've opened up that possibility in our playbook with this particular task.
Recognizing also that the professor or the teacher or the facilitator, whomever is going to be doing this, needs to make sure that the goals are achieved. That is an essential part of the whole process, is that when we talk about, I'll go back to my camera here, it's important that as a teacher, you're being intentional about what goals you want to achieve. If your goal is to help students define questions, that's absolutely necessary, and get them in groups and have them investigate their own stuff. But if you have a target you're trying to reach, be intentional. You can still have them explore, and there's still room for differentiation, because say my goal for the day is to have them develop the concept of area and have them develop the case where areas are equal. Well, I can have people work on that, and then I, as the teacher, can differentiate by saying, okay, you've thought about this area task, maybe I should ask a follow-up task that's more general or something like that still allows me to differentiate, that riffs off of this video.
Right? So I like the idea of like, how does this problem change if I replace the square with a triangle or the circle with a triangle? Right? Like, does that matter? Right? So I like the fact that just the problem itself has a lot of different entry points that students can explore. And like you said, it has a lot of potential follow-up questions if students need to dive in a little bit deeper too.
This happens a lot when people first. Let's see here. I was reading chat. The way they constructed the circle and squares in the beginning, Joseph says, makes the point of equal perimeter exactly halfway. And I think that's a really interesting observation. And students could make that observation and have that validated by a teacher. This goes back to our previous discussion about feeling included. I have an easy, like that's a very accessible way for you to get buy-in with the student. If a student says something, they have the opportunity to be validated for saying something that is true, and they can be included in the conversation. Whereas otherwise, they might feel marginalized if they didn't have the open entry point.
Yeah, and that's one thing I do notice a lot. Like when I'm teaching at the college level is different students are always going to see the problem in a different kind of way. And I don't think that's necessarily a bad thing, because what we, I think, try to do as humans as we're learning stuff is we're like, okay, there's this problem that I've been presented with, and I have to go through this process of, Liljedahl calls it problem solving, and it's kind of like a means end search. You're kind of like, okay, how do I connect this concept to something I've seen already, right? Can I bring in past experiences that and use those past experiences to help me solve this problem? And everyone kind of starts that process at a little bit of a different spot. And I think as educators, we just have to be mindful that exists, and help facilitate making those connections, right? In a way that makes sense and is meaningful, I think, to the students.
I like that. I like that a lot. So that's two examples of tasks that you can use and actually have authentic conversations with students and still develop the curriculum. This is another thing that we're going to get into in future episodes, but he differentiates between what's called a curricular task and a non-curricular task. And that often when you start your classes at the beginning of the year, you want to start with non-curricular tasks to help students get used to the idea. This mirrors something I learned in teacher school from some of my classes that said, you always want to teach something old in a new way, or something new in an old way, right? You never want to teach something new in a new way or old in an old way. You want to make sure that students have the opportunity to engage with it differently than they did before. So if you're teaching it in a new way, you should review with old things or things that are more familiar to students that don't require new content knowledge.
Yeah, one of my favorite tasks that I like to use in calculus is that visual representation where you take the square and you start subdividing the square and you start shading in smaller and smaller regions inside the square, and you end up kind of developing this infinite set of fractions that you're adding together. And then the students are like, well, wait a second, that actually adds up to something. And that opens up that conversation of, whoa, cool, we can add a bunch of stuff that's infinite in nature and potentially end up at a solution. And even before we start, you can say, okay, well, I have this square of area 1. So my answer has to be less than 1. Right? So you can kind of start setting that threshold of okay, I'm using a little bit of estimation to figure out what the upper bound is to this problem, and so on. Is that the video that you were sharing, Zach?
Yeah, I'm going to put these both in the chat, and we're going to have the show notes also have these.
Area 50.
Well.
Yeah, I think after we edit everything and get everything up to... what I'll be able to do when I'm editing is actually be able to hopefully sync up your voice a little bit nicer to the picture. And like I said, I'll have to try to figure out how to make that work the next time we get together. Because Discord is instantaneous, right? But your stream has a little bit of a delay in the audio. So
it does, and that's frustrating. But it's what we got to do. We do what we got to do.
Yeah, it is what it is for the time being. But yeah, definitely, I want to when we go to post this up on YouTube, we'll definitely put in all of our links so that you can reference these and review these, or maybe even potentially use these in your own classrooms.
Yeah. Okay, so what we've discussed today is what a task is, which is a problem that asks us to engage with math, ideally in a new way, and though it can be in an old way, but it invites us to think. And the most important part of a task to me, at least what makes a good task, if I'm going to apply the word good to it, is one that makes me think, one that makes me engage with math in a way that I haven't had to before. That's what the best mathematics does to me. And the tasks like we see on the board, like we saw on the board earlier, the more traditional things you give students may or may not do that. They can be good tasks. It just depends on the context in which it's given. And I think what Liljedahl, when I read all this and went through it, Liljedahl would advocate for giving tasks that invite us to think. And thinking, he's defined it as we talked about earlier, is getting rid of the mimicry, getting rid of the pretending to understand, getting rid of those points of like I having to fake it, and really trying to authentically learn through the process of doing.
Yeah, I would echo and agree those sentiments, and I liked. For me, the most important part of that discussion of that first chapter was that the task also has to be connected to, I guess, your learning outcomes, your goals, and also connected to the students, right? So there's this understanding of like a task that works really well for a certain group of students may not necessarily have the same outcome with a different set of students. And I think Liljedahl uses this phrase like routinized. So as students start to develop that knowledge and solidify that knowledge through tasks and through some practice, right? Those things start to become more routinized, and you can draw that information from your memory a lot faster. So as you know, like that first example of which is greater, 8 or 9. Well, a lot of us, I think, today and in this chat already know we've routinized that already. We know how that works. So that task isn't as exciting or engaging or motivating to us because we're like, well, why should I care about this question? It's not motivating to me, right? So I think choosing the task for the particular cohort of students in a engaging or motivating way somehow feels important to me too.
One last thought on that, because you reminded me of my teaching days in the K-12 world, where I had like 6 different periods of the same class, 5 or 6, in some cases. And I love the mug, by the way. Gotta love the mug. But sometimes I would give a set of tasks to one period, and the next period it wouldn't work so well.
Right.
Like this is true no matter even if you could have the same you're the same teacher in the same day, and certain groups may not react the same way to the tasks even across different sections or whatever of your course.
I mean,
I've had this happen.
Didn't we see that when you did sequences and series, like your real analysis class?
Yeah. When we did real analysis, that was like people would throw wrenches and things all the time. I remember.
Yeah, and I remember that like the morning group sometimes solved things differently than the evening group, which I thought was really interesting.
Yeah. I wanted to go back to chat for a second because I think JCYW brings up a really interesting point. I like the second video. The video literally had such a minimal amount of information. You're basically forced to make sense of it by asking what it's wanting you to do. And I think that's a really important point. Like sometimes not asking the question, and I know Dan Meyer would advocate for this in a heartbeat because he has almost in those words. Because you want to give you want the students to engage with material, and that's one way to do it is to help them think about the questions that they need to answer. helping them develop the question would be a very important part to him.
Yeah, and from my perspective, thinking about kind of how psychology and cognitive load plays into this, you always want the students to be thinking about what you want them to think about. So setting up the task in a way where you can use your questions to prompt them potentially in a direction that you think is going to be helpful. I think that feels like how we kind of make that bridge, right?
Yep. Cool.
Yeah, and if any of you are curious about the anti-epsilon mug, I've put a link into chat for you if you want to celebrate epsilon being less than or equal to 0.
Oh my gosh. That joke will never die.
It's one of my favorite things to say.
It just keeps getting smaller and smaller and smaller, that joke.
Stop.
I will.
There it is. There it is, chat. Our first dad joke. Finally happened.
Yeah.
Hollow. Yeah,
well,
thanks for the bumchishalo. Hollow.
Thank you.
All right. Is there anything else that you want to I think I feel like we've explored kind of what we were hoping to explore today, and if there's anything else as we kind of start to kind of wind down, I'm happy to talk about some things, or if chat has anything that they want to add in as we kind of start to wind down, I'm happy to chat about some stuff as well, Zach.
Yeah, no, it's fine. I think we've said what we need to say, and the big takeaway I hope we wanted to make sure is clear today is as Penn's thing says, students don't think, but tasks could help them do so. I think that title sums up nicely what we've talked about today, that students don't think, always at least from the data, but tasks can help them do so. And if you're in a teacher position of any kind, I invite you to do more tasks in your classroom and to pick up this book. Also, this book is amazing, and we're going to talk more about it in the coming weeks, of how to implement these tasks. Like Penn was saying, there's some implementation details. This may sound great to you in theory, but the next question should be, well, okay, that was cool, but how do I do something about this?
Exactly, right? So
right.
It's like, these are awesome. These are great tasks, and thank you for finding those tasks. And I think even though we aren't in an official classroom setting, I think you were able to at least give us some indication about how you might do that in your classroom, right? You're kind of coming along, looking at what students are doing, asking follow-up questions, kind of prompting them in the direction that you might like that conversation to go. And I guess I would add to that, are there other strategies that teachers can use to help facilitate that process, right? And I'm hoping that Liljedahl will have some more in store for me as I read some of the later chapters of the book.
It's exciting for sure. I love this stuff, and there's even more literature out there about best practices. So we're gonna go through all that, and if you've enjoyed what you've seen, share it with some other people, because this is something that we want to make bigger than ourselves, I think, and bigger than all of you. This is something we want to share with as many people as possible, and get into the schools, because often when you walk into the classroom, what you're going to see is what you've always seen throughout your whole mathematical career. For many of you, what you've seen around there, and to spreading this around, I think, will help us make the change we want to see in the world.
Yeah, so I think there's some good questions. Fem asks, how do you write a good task?
Yeah.
Good. Like, I feel like we could probably spend 2 podcasts just talking about that.
That's where we're going. That is something that I want to address, because it's something that I'm not perfect at, but I've gotten better over the years. And I'll try. I want to do some things in 2026. Stay tuned, everybody, for when I stream in 2026. I have some 2026 plans of something that I want to do that's connected to this podcast, but is sort of a spin-off in a sense. And we'll talk more about that in my stream, and I'll make announcements and so on for when we get to January. So don't get too excited yet, but I want to address that in a little bit more detail.
Well, you can't say that and not have everyone get excited, Zach.
Okay, fine. Get excited. Do it
5 minutes.
Welcome in, Inspector. I just started teaching high school math. Oh, amazing. How's everything going so far, Inspector?
That's awesome. I was gonna say that's a hats off to you for doing it. That's amazing. I'm no longer in the classroom, but it was fun. It was a good time when I did it.
Unobserved. Until
I'm
you
interested in your
sample the
experience.
mug, Penn's
But I
caffeine
think I'll
state
sign
is
off, Pen.
superposed.
If that's it,
Late
then
night?
we're gonna sign
That
off and
decaf.
say goodbye to you
Ask
all.
him or sniff
I
the
appreciate
cup.
you. Thanks for watching,
Zeta
and
uncertainty.
I hope you have a great day.
Yeah, thanks so much for I guess bringing this opportunity forward. I think this is something that you and I have we've certainly talked about this over the past year, and it's so exciting to finally have it come to fruition, and I'm super excited to see where things go. I think based on kind of our numbers and the way chat's been popping off today, that people are excited to talk about this kind of stuff. So I certainly hope that all of you will come back in the future, like bring your questions, bring some of your experiences, and let's just start this conversation and see where things go.
I'm excited,
Define
and
goal,
we're gonna put this out on
strings.
YouTube. We've got
Give
Beyond the
clear
Blackboard
IO.
podcast is where it's gonna
Give
be.
example
I'll give you a
plus
link to
edge
that.
cases.
Um,
Specify
but
evaluation. Set time, space
we're
limits.
gonna put the VOD there.
Ban ambiguity. Be concise.
spell.
Zeta clarity. Diff scope.
Hold
Integrate value.
Hold on, I promise we'll get it.
Sigma.
It's all good. It's all good.
Wait, do we? Okay, I think it's gonna be right here when it's done.
Yep, that looks correct. Beyond the Blackboard -podcast. That's going to be our new YouTube channel for this podcast specifically. So yeah, feel free to join us over there.
Decompose to small.
The VODs will be I'll
names.
certainly be
Big
posting the
data
VOD
structures.
on Twitch, but I'll be
Minimize
probably doing a
big
little
O.
bit of video
Write
editing
tests,
before
lint
they get
format,
officially
handle
posted onto
errors,
YouTube,
log,
just to kind of,
iterate,
especially for this one, to try to line Zach's
refactor,
voice up a little bit
Zeta
better
readable,
with the visuals. So.
QAD.
We're gonna get better over the months as we do this more and more. But I invite you to go and also give Penn a follow if you're watching me. Give Penn a follow. Please do that. And check out Penn's streams. He'll be streaming Sunday, some data science. And tomorrow, aren't you doing some Legend of Zelda? I think that's right.
Yeah, tomorrow it'll be around 5 o'clock Pacific. We'll be doing a multi-world stream with Leo and Dexy. And then I'll be back Sunday after work at the brewery. We'll be doing some data science on Sunday. So that'll be my next master.
Let's see the solution of your advanced algorithms come true.
Walking stick, that's going to be that where it is. It's not up yet, you're right, but it's going to be there.
Fine, I'll integrate.
So give us a little bit. Once we get the first episode up, we'll be fine.
Time for a pop quiz.
Yeah, so that's that. And then I will be streaming tomorrow, doing my normal question and answer session. And next time will be... Oh, hold on, I gotta grab it. Oh, no, Fembox, no! 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 Curses!
That's funny.
Oh, dang it. Okay, I almost got the mental math. You're a split second faster, Fembox.
There you go, Fem.
Well done. Well
Hardly
done.
even a practice test.
Grr. Eat them's turn. We'll call that one.
That was pretty close, both of you. Yeah.
That was close. Yeah. Yeah. Anyway. Okay. Well, thank you, Penn. Thank you, chat. Thank you, everybody. We'll get the VOD up there, and I will post the link also in both of our Discords once we got the VOD up there. So it won't be an empty link like Walking Stick was saying. It currently, I think, is empty, but that's the placeholder for where it will be. Get excited for it. We'll catch y'all next time.
All right. Thanks again, Zach. Take care.
Yep. Bye-bye.
Do we have anybody online? Let's see. Should we do a little raid out to somebody?
Hold on. So let me raid over to you. I'll raid my viewers on over, and then I'll let you take them where you want to go.
Beautiful. I'm going to leave that. We'll head back to Twitch. I know that it looks like Tinker's on. But I'm just going to quickly have a peek to see if anyone else is kicking around over here. Yeah, it looks like just Tinker for now.
Brace yourselves, everyone.
There's the raid. Thanks for the raid, Zach.
No problem.
Internet's being a little slow on me here, so give me a hot second here, everybody.
I'm trying to see if there's anybody I have we can raid. We've got. There's a lot of people on, actually.
Yeah, if you have a suggestion, feel free to let me know.
I have. Let's see. If you want to raid Shark Geek, we could do that. They're playing a game, RV There Yet. I've not played this before.
RV There Yet? So they're called Shark Geek?
Shark Geek at Shark G33K. They're like the lead spelling.
Shark G33K?
That's right.
All right, let's do it.
Let's go say hi to Shark Geek. It's a friend. Catch you later. And then we can talk about the...
Yeah, I'll stay on the call after I sign off.
For a second.
Yeah,
okay, cool.
Good. All right, thanks, everyone. We're going to sign out. We're going to go take a look at what Shark Geek is up to. We'll post some raid messages into the chat if it works, so you can copy and paste one of those if you'd like. Boop, I will copy one myself. Have a fantastic rest of your day, and we'll catch up with you guys tomorrow and Sunday. It's a crazy week of streaming for me. I'm very excited to be back and back to streaming. So super excited to chat with you guys a little bit later this week. Take care.